Don't forget to subscribe and press the bell icon to never miss a video from testbook.com.
Alright, so welcome back. Welcome back to the Theory of Machine sessions at the testbook.com gate channel. ठीक है, तो आप लोग का अगेन बहुत बहुत वेलकम है on testbook.com gate channel. So in this beta we were talking about in this my dear we were talking about the theory of machine, and in the last session my dear we have completed what are the different classifications of the pairs, right? In the last session, what we have seen in the last session, if you have not seen the last session, please go subscribe the channel, subscribe to testbook.com. Please go for it. Please watch all the previous videos, because at a time so many subjects are running for you. Okay, as in session in this continuation, we are dealing with the theory of machine every alternate day. So what does that mean? So today there is a class, now tomorrow there won't be a class, now day after tomorrow there will be another class. Okay, at the same time 3:30 only on testbook.com gate channel, right? So please do subscribe it. Please do subscribe it. Please do subscribe the channel. And also, before starting up, I would like to give you one more information, that is that the GATE 2022 live sessions are already started. Okay, on the website. Okay, you can see this. Okay, so GATE ME 2022 live coaching is already started. Okay, and along with that, we have this complimentary yearly textbook pass as well. Okay, so my dear, this is a very very good opportunity. Please go and check it out. Please go and check it out. All the faculties are very very experienced. It's a very very good platform, and after every session, you are getting the notes of the classes. Whatever is being done in the class, that is the notes provided. Along with that, short notes are also provided, PDF notes are also provided. Along with that, after each and every session, you will be getting practice questions. You will be getting practice questions related to that topic. So it is the best platform to continue your preparation for GATE 2022. If you are a serious aspirant, my dear, this is the best thing that we can move ahead. Now let's begin with today's content. Okay, so let's begin. So in the last session, we have seen what are the different kinds of kinematic pairs. What were the different types of kinematic pairs, and we discussed those, I think, in the sufficient depth. Now, so we have started with the link in the first session. Okay, so this is the fourth session in this series. In the first session, I told you about how we can proceed in the design subjects like theory of machine. In the second topic, we started with the content, and in the second session, we have talked about the links, the type of the links, the relative motion. Okay, types of the links, what can be the types of links, what is the basics of the subject. In the next session, in the other session, in the what we can say the third session, in the last session of this session, what we have seen what is the type of relative motion, how constrained motion is different with unconstrained motion, how completely constrained motion is different with successfully constrained motion, right? Successfully constrained motion. Okay, now in this session, we are going to talk about kinematic chain. Okay, so all the live students may respond to me. All the live students, I would like you to respond to me. So, what is a kinematic chain? Now, what is a kinematic chain? What is a kinematic chain? So, kinematic chain. So, in the last session, first session, we have seen kinematic link. Then we have seen kinematic pair, and today we are going to start with the kinematic chain, right? Right. So, what is a kinematic chain? Can you answer me? What is the kinematic chain? The students who are live in the session may respond to me. What is the kinematic chain? Okay. Okay. Let's do one thing. Just forget about the kinematic part. You describe me what is a chain. What you call a chain? What is a chain? What is a chain? How can you call something a chain? Can you tell me? Can you tell me? Now, if you remember, if the first link, now, So what we can call a chain, so if the first link is connected to, the last link, if the first link is connected to the last link, it is always a chain. It is always a chain. Okay. कभी भी अगर पहला लिंक आखिरी लिंक से कनेक्ट होता है किसी भी चीज में, अगर पहला लिंक और आखिरी लिंक अगर बेटा आपस में कनेक्ट हो गए, पहला लिंक आखिरी लिंक आपस में कनेक्ट हो गए, तो डेफिनेटली इट इज समथिंग कॉल्ड अपॉन एज अ चेन. समथिंग इट इज कॉल्ड अपॉन एज अ चेन. ओके. ओके, किसको चेन कहते हैं? अगर फर्स्ट लिंक एंड द लास्ट लिंक आर कनेक्टेड टू ईच अदर, उसको बेटा हम चेन कह सकते हैं. नाउ for that chain, now for that chain to be, for that chain to be a kinematic chain, for that chain to be a kinematic chain, the motion between the links must be constrained. So if you remember in the last session also I pointed this out, whenever you see this term kinematic, it is always always analogous to constraint, right? Yes or no? Yes or no? Okay. So if you are live students can please respond to me on this. Live student can please respond to me on this. So if something is there, so if a chain is to be a kinematic chain, so if you remember, I told you in the last session that something, if kinematic is a word is there, if kinematic word is attached to something, if kinematic word is attached to something, it is like this thing is going to come, constraint motion. Okay, constraint motion. So anything when we call it kinematic, so it is referring to the constraint motion, right? It is referring to the constraint motion. Now moving ahead, now we started with the link. If you remember, from link we have seen the types of link, the relative motion types, and with the link, my dear, we move to the pairs. Okay, so kinematic link, from kinematic link we move to kinematic pair. Now we today reach the point where we can talk about kinematic chain. Now from the chain, how we can make a mechanism. So we, by fixing a link of a kinematic chain, we may form a mechanism. So from chain, how a mechanism is formed? It is formed by fixing a link. So from kinematic chain, how we can form a mechanism? We can form a mechanism by fixing a link of that chain. So when we fix any link of the chain, it may become a mechanism. Okay, so from a kinematic chain, how we can form a mechanism. Now from this, can we comment? So there are some statements that confuse the students. So every kinematic chain is a mechanism. Remember, I never have written simple mechanism. Every kinematic chain is some sort of a mechanism. May or may not be simple mechanism. Understood, beta? Understood. Remember, do not put words on your own. Every kinematic chain is a mechanism. Never I have written, deliberately I have not written simple mechanism. It is not that I missed it. Okay, the name of the chapter is simple mechanism, where we are talking about it. Now every kinematic chain is a mechanism, right? every kinematic chain is a mechanism. Now when every kinematic chain is a mechanism, so from a chain, how we can form a mechanism? From a chain, how we can form a mechanism? We can form a mechanism if we fix a link of it. For example, I keep drawing this diagram for you. No, I keep drawing this diagram for you. So we have a cylinder, we have a piston, we have a connecting rod, and we have a crank. And now the crank is again connected to the fixed one, right? Again connected to the fixed one. Agreed or not? Agreed or not? Now, beta, unless I fix something in here, like if I do not fix the cylinder, if I do not fix a cylinder, if I do not fix a cylinder, if I do not fix a cylinder, okay, if I do not fix a cylinder, okay, if I do not fix this cylinder, this is of no use. Now without fixing it, it was a chain because the first link was connected to the last link, right? In this we can say without fixing anything, it was a chain. But to have some use of it, we need to fix one link. At least one link is to be fixed. At least or at most, whatever you say, only one link at a time is going to get fixed. Now, if I fix this, if I fix this, then only it has become a kinematic chain, then only it is a constraint mechanism, because in the last session also we have spoken about it that the piston always reciprocate, piston हमेशा reciprocate करता है, and crank always rotate. Now every time when piston made to reciprocate, the crank is made to rotate at all times, right? जब भी पिस्टन को रेसिप्रोकेशन मिलता है तो क्रैंक को हमेशा रोटेशन मिलता है, तो कैन वी से द मोशन ऑफ दिस सिस्टम इज कंस्ट्रेन्ड? यस, सर्टेनली यस. सो इट इज अ मैकेनिज्म नाउ. Now it is a mechanism. Now I want to ask you something. Now my question to you is, please respond. So what is the difference in mechanism and machine? Are they both the same thing, or if there is any difference in it, please tell me what is the difference between them. बताइए, what is the difference between them? Can you tell me that, beta? Can you tell me that? What is the difference between them? बताइए. Please answer me. So what is the difference between mechanism and machine? So those who are live can respond to me, please. What is the difference of a mechanism and a machine? Are they the same thing? Are they the same thing? क्या वो same thing है? What is the difference in mechanism and machine? Are they the same thing? Okay, so they are not the same thing. Okay, so from kinematic chain or a chain, because even a chain can form a mechanism. Okay, so from a chain, if we fix one link, we will get some mechanism. Okay, we will get some mechanism. Now, how this mechanism is different from the machine? Now, from this mechanism, remember, when I can get a machine, when I now please listen to me very very carefully. When we define इनपुट एंड आउटपुट, जब हम इनपुट एंड आउटपुट को डिफाइन कर देते हैं, when we define input and output, we are going to get a machine from a mechanism, right beta? Right, so this is a mechanism, this is a mechanism, this is a mechanism, this is a mechanism Okay, this is a mechanism where piston always reciprocate and crank always rotate. Okay, piston always reciprocate and crank always rotate. Getting my point? But a piston always reciprocate and crank always rotate. Now it is a mechanism. Now it is a mechanism. This is a mechanism. Now from this mechanism, if I call it an engine, so certainly engine is a machine. If I make it a machine, if I want to make it a machine, so engine is obviously a machine. So in engine, if we are calling this arrangement a engine, so definitely we are taking input at the piston, we are taking input at the piston and output at the crank. Output at the crank. Getting my point, beta? Output at the crank. Right? Right or wrong? So when piston is reciprocating and crank is rotating, when the piston is reciprocating and crank is rotating, whenever the piston is, whenever a piston is, whenever a piston is reciprocating and crank is rotating, whenever a piston is reciprocating and crank is rotating, so we got the constrained motion. Constrained motion is achieved, but to call this arrangement a machine, we need to define where we are taking the input and where we are taking the output, where we are taking the input and where we are taking the output. So if we call this thing as an engine, so definitely we are taking the input at the piston and output at the crank. Similarly, the same arrangement is sometimes called as reciprocating compressor. So let's just call it compressor here. So if it is a compressor, my dear, if it is a compressor, my dear, input will be at crank and output at piston. Okay. Okay, getting my point, beta? Getting my point. So from mechanism, from the same mechanism, we are getting two different machines that serve different purposes, isn't it? So भैया यहाँ से हमको क्या मिल रहा है? हमको यहाँ से एक ही मैकेनिज्म से दो डिफरेंट मशीन्स मिल रही हैं. हमको एक ही मैकेनिज्म से दो डिफरेंट मशीन्स मिल रही हैं. हमको एक ही मैकेनिज्म से दो डिफरेंट मशीन्स मिल रही है जो डेफिनेटली डिफरेंट पर्पसेस सर्व करती है. तो इसी मैकेनिज्म से अगर मैं इनपुट पिस्टन पे ले लूँ, आउटपुट क्रैंक पे ले लूँ, तो मुझे इंजन मिल जाता है. और इसी मैकेनिज्म में अगर मैं इनपुट क्रैंक को दे दूँ और आउटपुट पिस्टन पे ले लूँ, अगर मैं इनपुट क्रैंक को दे दूँ और आउटपुट पिस्टन पे दे दूँ, तो इसी मैकेनिज्म को मैं कंप्रेसर के नाम से जानने लगता हूँ. इसी मैकेनिज्म को मैं कंप्रेसर के नाम से जानने लगता हूँ. ठीक है. सो बेटा क्या समझ में आया? क्या समझ में आया ओवरऑल? तो बेटा हमने लिंक से पेयर बनाई. देखिए अब आप थ्योरी ऑफ मशीन में एंटर करते हैं. आज तक हम थ्योरी ऑफ मशीन के आजू बाजू घूम रहे थे. सब्जेक्ट के नाम में है थ्योरी ऑफ मशीन. तो मेरे गुड इवनिंग भारत. सो गुड इवनिंग. सो बेटा अभी तक हम मशीन सब्जेक्ट के आजू बाजू रिवॉल्व कर रहे थे. तो अब सब्जेक्ट में सही मायने में एंट्री हुई. सो लिंक से हमने पेयर बनाया. कैसे बनाया आपको पता है. पेयर कितने टाइप के होते हैं, क्या होते हैं, हर में क्या खूबी है, लोअर पेयर हायर पेयर क्या होता है, सब बातें आपको पता है. नाउ फ्रॉम द पेयर वी फॉर्म द चेन. पेयर से हमने क्या बनाई बेटा? चेन बनाई. चेन से हमने बाई फिक्सिंग अ लिंक हमने मैकेनिज्म फॉर्म किया. बाई फिक्सिंग अ लिंक हमने मैकेनिज्म फॉर्म किया और इस मैकेनिज्म से हमने मशीन कैसे बनाई? हमने इस मैकेनिज्म से बाय डिफाइनिंग इनपुट एंड आउटपुट कि हम मैकेनिज्म में इनपुट कहाँ ले रहे हैं एंड आउटपुट कहाँ ले रहे हैं. बाय डिफाइनिंग इनपुट एंड आउटपुट, by defining input and output, we have formed the machine from the mechanism, and now we can start in all the necessary depth the theory of machine. तो I would like to welcome you all in the world of theory of machine. अब आप लोगों का theory of machine में स्वागत है. बताइए बेटा, कोई डाउट हो तो बताइए यहाँ तक, अदरवाइज अब मेन कंटेंट पे चलते हैं. देखिए सब्जेक्ट की खूबी देखिए बेटा, 3-4 घंटे तो सब्जेक्ट में पढ़ना क्या है और सब्जेक्ट में जानना क्या है, सब्जेक्ट की डेप्थ क्या है, यही समझने में लग जाता है. राइट अगर आप गेट के लिए पढ़ रहे हैं, इट इज अ ब्यूटीफुल पेपर. एवरीथिंग इज इम्पोर्टेंट, everything is important there, my dear. Everything is important there. Okay, okay, okay. Understood or not understood, my dear? Understood or not? Now, those who are live can respond to me, please. Alright, so I hope it is fine to all of you. I am hoping it is fine to all of you. Now, beta, let's start with the heading of this video, that is degree of freedom. Okay, okay. Now, in the last session, बेटा मैंने आपसे कहा था, in the last session I told you कि इस सब्जेक्ट में हमें फ्रीडम चीज़ों की ख़त्म करनी है. ठीक है, हमें चीज़ों को फ्रीडम देना नहीं है, बल्कि उनका फ्रीडम ले लेना है. ठीक है, द मोर वी टेक देयर फ्रीडम, द मोर यूजफुल दे विल बिकम. जितना उसके ऊपर रिस्ट्रिक्शन होगा, जितना उसके ऊपर रिस्ट्रिक्शन होगा, ठीक है, जितना भी रिस्ट्रिक्शन होगा, गेटिंग माय पॉइंट बेटा, जितना ज़्यादा रिस्ट्रिक्शन होगा, जितना उसका मोशन कंस्ट्रेंट होगा, उतना ही ज़्यादा वो यूजफुल बनेगा. नाउ लेट्स अंडरस्टैंड व्हाट इज द डिग्री ऑफ फ्रीडम. सो कैन एनीबडी डिफाइन इट फॉर मी? इफ आई आस्क यू व्हाट इज द डेफिनेशन ऑफ डिग्री ऑफ फ्रीडम, now this word you might have observed in the strength of material as well. इस strength of material में भी देखने को मिलता है. If you are learning the thermodynamics, that is also going on the channel, so please do not forget to subscribe it. Okay, fluid mechanics चल रहा है, HMT चल रहा है, heat and mass transfer चल रहा है, thermodynamics चल रही है, SOM चल रही है, theory of machine चल रही है. एक साथ इतने सारे सब्जेक्ट बेटा किसी प्लेटफॉर्म पे at no cost, एकदम free fund, and we are promising that we are going to continue it for the next 3 months, 3 month. और 3 मंथ बेटा आप फॉलो करेंगे तो आपके 6-7 सब्जेक्ट क्वेश्चन और कॉन्सेप्ट के साथ काफ़ी हद तक ख़त्म हो जाएंगे. राइट, सो प्लीज़ डू नॉट फॉरगेट टू लाइक एंड सब्सक्राइब द चैनल. लाइक और सब्सक्राइब करना बिल्कुल मत भूलिएगा. नाउ कमिंग टू द डेफिनेशन ऑफ डिग्री ऑफ फ्रीडम. नाउ कैन एनीवन टेल मी द डेफिनेशन ऑफ इट? The other day I saw Siddharth sir was explaining it in the thermodynamics part on the channel. ठीक है? Now what is the definition of degree of freedom in context with the theory of machine? So I can define it like this. So we can define it like this. So what is the definition of theory of machine? What is the definition of theory? What is the definition of degree of freedom? I'm sorry, I misspelled it. So definition of degree of freedom, क्या definition होता है? तो it is the number of independent motions, और we can say चलो generally define कर देते हैं, general definition दे देते हैं. It is the number of independence variable required to define the motion position, motion and position ऑफ अ सिस्टम. ठीक है. सो मतलब क्या है कि डिग्री ऑफ फ्रीडम क्या होता है, ये इंडिपेंडेंट वेरिएबल्स होते हैं. किसी भी सब्जेक्ट में आप देखेंगे, सॉम में भी यही होता है, थर्मोडाइनमिक्स में आप देखोगे वहां भी यही होता है. थर्मोडाइनमिक्स के हिसाब से क्या डेफिनेशन है, इट इज द नंबर ऑफ इंडिपेंडेंट इंटेंसिव प्रॉपर्टीज. Independent intensive properties required to define the state of a system. Similarly, यहाँ पर क्या definition है? It is the number of independent variables required to define the motion and position of a system. So, what is the number of independent? So, I want you to see. अभी ये definition हो सकता है आपको पूरी तरह समझ में ना आए, धीरे धीरे समझाता हूँ. So, ये independent. What do you mean by this word independent? First of all, take a note of it. ओके. इंडिपेंडेंट. नाउ अब इसका जरा आसान भाषा में अगर हम इसको समझने चले तो इन 3 डायमेंशन. सो लेट्स फर्स्ट टॉक अबाउट इन 3 डायमेंशनल सिस्टम. इन 3 डायमेंशनल और 3D systems. In 3-dimensional system, so let's say we got a body in a 3-dimensional plane, in a 3D plane. So हमारे पास यहाँ पे 3 प्लेन है. let's say x है, y है and z है. we got 3 planes here, x, y and z. now we got a body on here. हमारे पास एक बॉडी है in this x, y, z orientation. now can you tell me how many motions are possible which can be taken by this body? ये बॉडी कितने मोशंस ले सकता है? हाउ मेनी मोशंस इज पॉसिबल ऑफ दिस बॉडी? हाउ मेनी इंडिपेंडेंट, आई मस्ट से, हाउ मेनी इंडिपेंडेंट मोशंस आर पॉसिबल? हाउ मेनी इंडिपेंडेंट मोशंस आर पॉसिबल? हाउ मेनी इंडिपेंडेंट मोशंस आर पॉसिबल ऑफ दिस बॉडी? नाउ कैन यू रिप्लाई मी दैट? How many independent motions are possible of this body? Can you reply me that? How many independent motions are possible? How many independent motions are possible? Independent means which doesn't depend upon any other direction. जो किसी और direction पे depend ना करे. Can you answer me that, बेटा? Can you answer me that, बेटा? Can you answer me that, बेटा? Can you answer me that, my dear? एक बार ट्राई करेंगे. कितना इंडिपेंडेंट मोशन है? 100. बहुत बार ये सवाल आप लोगों से एग्जाम्स में पूछा गया है. बहुत बार ये सवाल आप लोगों से एग्जाम्स में पूछा गया है. कैन यू आंसर मी दैट, माय डियर? कैन यू आंसर मी दैट, माय डियर? बताइए. How many independent motion this body possess when it is in the space? Okay. And if I say by a question, so it is asked many times in many examinations. So how many motions a body possess when it is free to move? How many independent motions a body possess when it is free in space? बताइए बेटा, बताइए. हाउ मेनी मोशन दिस बॉडी पोसेस? कितने मोशन है इसके पास? नो. कैन इट मूव इन एक्स डायरेक्शन? प्लीज ऑब्जर्व. क्या ये एक्स डायरेक्शन में जा सकती है? क्या ये एक्स डायरेक्शन में जा सकती है? हाँ जी सर, बिल्कुल जा सकती है. क्या ये वाई डायरेक्शन में जा सकता है? हाँ जी सर, बिल्कुल जा सकता है. क्या ये जेड डायरेक्शन में रेसिप्रोकेट कर सकता है? हाँ जी सर, बिल्कुल रेसिप्रोकेट करता है. बिल्कुल रेसिप्रोकेट कर सकता है. राइट. जैसे मेरे पास ये एक 3 डायमेंशनल बॉडी है, मेरा मोबाइल. नाउ दिस बॉडी कैन मूव इन एक्स डायरेक्शन. ओके. This body can move in y direction like this, and this body can move in z direction. Sir, why not we move it like this in an angle? Why not we move it like this in an angle? Why not we move it like move this in an angle? Why not Why not do not move it? So definitely we can move it at angle, but that won't be independent, because when you move something at an inclined position, let's say this is your x, and you are moving something in xy plane, let's say in xy plane, you are moving something, you are making this body to move in this direction. Now, is this motion independent to x and y? Definitely not. Definitely not independent of x and y. Simply, if it is moving at a velocity v, you will find a component here, v cos theta. Right? Getting my point or not, beta? Getting my point, and there will be v sine theta. V sine theta. Okay? Okay, so definitely this v depends upon the velocities in x and y direction. So that is why we talk about only x, y and z direction. Why I am quoting you this? Because sometimes the student asks, sir, it has infinite independent motion. A body in space, if it is lying in space, it can go in any direction. What's the problem in that? It can do anything. No, it cannot. So when we are saying degree of freedom, that is why I told you, that is why, my dear, I told you this, that this independent word is very, very important here, right? This independent word is very, very important, because the motion we are talking about should be independent. It must not be the function of any other direction. As you can see here, if this body is moving in the theta direction, if this body is moving in the theta direction, if this body we see to be moving, if this body we see to be moving in theta direction, so definitely that is not to be deemed as, or that is not to be considered as independent motion. So ये motion, my dear, independent नहीं है. ये motion, my dear, is not independent. Now what are the independent motion कितने हैं? So it can move in x direction, it can move in y direction, it can move in z direction. Now this body can rotate about x, right? So if the body rotates about x, it will be rotating in yz plane. If this body rotates about y, so this would be rotating about in a xz axis. And similarly, if this body is rotating about z, so this body would be rotating in xy plane. Okay. So how many independence? So clockwise, anti-clockwise doesn't mean anything. Now, if you read this subject manufacturing science, there is a topic 3-to-1 principle. There you will be seeing that they are considering 12 degree of freedom. In theory of machine, we take it 6. How they take it 12? So they consider plus x minus x 2 independent motions. Getting my point? So 3-to-1 principle, my dear, it is a principle. 3-to-1 principle क्या होता है? It is the principle related to the jigs and fixture, work holding device. वर्क किसी जॉब को होल्ड करने के लिए हमें कितने डायरेक्शन मोशन को डिस्ट्रॉय करना होगा, वहां पे वो बात करते हैं. तो वहां पे 12 मानते हैं. प्लस एक्स का एक, माइनस एक्स का एक, प्लस वाई का एक, माइनस वाई का एक. ठीक है, इस तरीके से क्लॉकवाइज एंटी क्लॉकवाइज. तो वहां 12 मानते हैं. इन थ्योरी ऑफ मशीन, so a body in space, so it can have 6 independent motion. Okay, and with this we can say, so a 3-dimensional body, a 3D body can have, maximum 6 degree of freedom. So when a body is free up in space, it is having no restriction, it is just lying in the space, so it can have 6 degree of freedom, it can have 6 independent motion. Now let me tell you, in the language of theory of machine, I can bluntly say, now it is having no use, or it is very, very difficult from it to make some use of it, because it has got too much freedom. It has got too much freedom. Okay, so some freedom is good, but more than the freedom, more than so too much freedom, more than what is required, is not good. Okay, if we follow this thing in the life also, we'll be yielding to something. Okay, Okay, so like on YouTube, I want to see some songs, but if you are watching me, then definitely you are on the right track. Right, my dear. Okay, so sometimes in the life also we need to restrict ourselves. We need to cut down some of our freedoms. So that is how we are going to approach in this subject. We are going to restrict some of the degree of freedom so that we can make some use of out of it. So our 3D body, when having 6 degree of freedom, it is of no use. So what we are going to do, so in 3 dimension, if I say, the degree of freedom can be found by degree of freedom. What is the degree of freedom that we are going to see now? So the degree of freedom in 3 dimensions, so we will call it as degree of freedom. It will be 6 minus number of restraints or number of constraints. 6 minus number of restraints. Getting my point, beta? 6 minus number of restraints. Now what do I mean by it? So a body in 3D has maximum 6 number of degree of freedom. Now as I said, when it is having this much freedom, this so much freedom, we cannot make any use of it because we want to constrain the motion, right? We established this thing in the previous session. If you do not have watched it yet now, till now, if you have not watched it, अगर आपने नहीं देखा हो तो प्लीज चैनल को सब्सक्राइब करिए, बेल आइकन को भी क्लिक कर दीजिएगा, ठीक है? अपने टेक्स्ट बुक के गेट चैनल को सब्सक्राइब करिए, जाइए जा करके देखिए वीडियोस। तो प्रीवियस वीडियो में हमने बात की थी कि किसी मशीन को यूटिलाइज करने के लिए हमें उसके मोशन को कंस्ट्रेन करना पड़ता है, एक इनपुट पे एक आउटपुट करना चाहिए, ठीक है? दैट इज द मोस्ट डिजायरेबल थिंग। और यूनिक आउटपुट तो नेसेसरी है। तो अगर डिग्री ऑफ फ्रीडम बेटा हमारी मैक्सिमम 6 है और अगर हम बॉडी को कोई रिस्ट्रिक्शन ना दें तो बेटा उसको कोई डायरेक्शन नहीं मिलेगा, उसका कोई यूज नहीं हो सकता। अब आप सोचिए, मैंने आपको पीछे के सेशंस में एक एग्जांपल दिया था कि आप उस मोटरसाइकिल का कभी इस्तेमाल नहीं कर सकते हैं जिसमें आपको ये श्योरिटी ना हो कि जब आप एक्सीलरेटर पुल करोगे तो उसके साथ क्या होगा, राइट? जब आप एक्सीलरेटर पुल करोगे तो वो मोटरसाइकिल कैसा बिहेव करेगी, क्या रिस्पॉन्स देगी, अगर आपको ये क्लियर ना हो, ठीक है, अगर आपको ये क्लियर ना हो तो बेटा उस मोटरसाइकिल का जिंदगी में कोई इस्तेमाल नहीं हो सकता। सोचिए, आप एक मोटरसाइकिल, मतलब ये बात इस तरीके से समझिए, आप एक मोटरसाइकिल ड्राइव कर रहे हैं और जब आप उसका एक्सेलरेटर लगाते हैं या एक्सेलरेटर पुल करते हैं तो दैट मोटरसाइकिल कैन गो इन 6 रैंडम डायरेक्शन। 6 डायरेक्शन इंडिपेंडेंटली वो जा सकती है, 6 रैंडम डायरेक्शन में जा सकती है। तो क्या कहोगे, सर ये तो अच्छी बात है, सर ये तो बहुत अच्छी बात है, हम एक साथ 6 दिशाओं में जाएंगे, बताइए ऐसी बात करेंगे? एनीवन हैव दिस लॉजिक? बताइए कि सर ये तो अच्छी बात हुई ना, अगर एक मोटरसाइकिल हम एक्सीलरेटर दबा रहे हैं और एक साथ 6 डायरेक्शन में जा रहे हैं, तो बेटा एक साथ 6 डायरेक्शन में जाओगे तो क्या होगा? चल पाएगा काम? तो आई डोंट थिंक नहीं चल पाएगा, राइट? So that is why we need to restrict some of the degree of freedom. So like for this body, if I say, so this body now it is lying up in the space, so it can move in any direction. Right? It can move in any direction, like you. So you want to go in any direction, you can go watch movies also, ठीक है? बट आपको अपने लिए वहां पे रिस्ट्रिक्शन लगानी पड़ेगी, आपको बेटा रास्ता रोकना पड़ेगा, राइट बेटा? यू वांट टू गो इन द फ्रंट साइड ऑल्सो, तो वहां पर भी बेटा आपको रिस्ट्रिक्ट करना पड़ेगा, बैक एंड में भी रिस्ट्रिक्ट करना पड़ेगा। गेटिंग माई पॉइंट मतलब आपको कुछ एक बात समझिए, ऐसा करते हैं 3 डायमेंशन बनाते हैं, ठीक है? 3 डायमेंशन में बना के दिखाता हूँ। So when we have, so let's consider ourselves as a system. अगर हम अपने आप को ही सिस्टम समझ करके बात करें, so we got this, ठीक है? हमारे पास दो तरफ हमने वॉल खड़ी कर दी है, ठीक है? ऑलराइट, ये दो साइड बेटा हमने क्या कर दी, हमने वॉल लगा दी, ठीक है, इधर भी वॉल है, इधर भी वॉल है, ठीक है, और हम यहाँ पे खड़े हुए हैं, वी आर हेयर। ओके, नाउ फ्रॉम द बैक ऑल्सो आई एम पुटिंग सम वॉल्स, मैंने बैक में भी वॉल लगा दिया, फ्रॉम टॉप ऑल्सो आई एम पुटिंग सम वॉल, ठीक है। मतलब क्या है कि भैया अब मैं इधर भी नहीं जा सकता, उधर भी नहीं जा सकता, नाउ आई कैन मूव इन फ्रंट, ठीक है, मैं केवल सामने की तरफ चल सकूंगा, आई कैन मूव इन द फ्रंट डायरेक्शन ओनली टूवर्ड्स माई गोल्स, एंड इफ दैट इज गेट, सो यू हैव टू रिस्ट्रिक्ट योर सेल्फ। हम ऐसा ही होता है ना, पढ़ने बैठे हैं, हम पढ़ने बैठे हैं लेकिन मन कर रहा है लाओ यार थोड़ा देर मूवी देख लें, लाओ चलो थोड़ा घूम के आ जाए, है ना, है ना। सो अगर आप अपने आप को अपनी लाइफ में रिस्ट्रिक्शन नहीं देंगे, सो कैन यू अचीव द गोल्स बेटा, बताइए बताइए, कैन यू अचीव द गोल्स। सो राइट नाउ बेटा, व्हेन somebody, when some student is in the space, it can move in any direction he wants, he can move in the any direction he wants, but now if you move in one direction, if you focus on one direction, if you reduce your freedom to one, if you make your degree of freedom one, definitely we are going to achieve any goal in our life, that may be GATE 2022 as well. ओके ओके बेटा, तो जब आप स्पेस में ऐसे अभी खड़े हुए हैं तो आप 6 डायरेक्शन में जा सकते हैं, लेकिन कोशिश क्या करनी है, अपनी डिग्री ऑफ फ्रीडम को कम करके एक डायरेक्शन में जाना है, अपनी डिग्री ऑफ फ्रीडम को कम करके बेटा एक डायरेक्शन में जाना है। जैसे अगर मैं इस बॉडी की बात करूं, नाउ अगर इस बॉडी को मैं सब तरफ रिस्ट्रिक्शन लगा दूं, एक्सेप्ट अगर मैं इसको इधर तरफ से भी रिस्ट्रिक्ट कर दूं, इधर 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 भी रिस्ट्रिक्ट कर दूं, नाउ beta, in which direction it can go, so it can go in only one direction, so now what is the degree of freedom, so it cannot rotate as well, so how many restriction, मैंने कितने motion destroy कर दिए बेटा इसके, how many motion I have destroyed of this body, इस body के कितने motions को मैंने खत्म कर दिया, so I have destroyed 5 motion of this body, and now this body can move in only one direction, this body can move in only one direction, so that is why we can call that the degree of freedom of this body is 1, degree of freedom of this body is 1। now बेटा, now देखो मतलब क्या है, मेरे ख्याल से आपको ये लॉजिक तो समझ में आ गया होगा कि हाउ टू मेक कैलकुलेशंस ऑफ अ 3D body when asked about the degree of freedom। so degree of freedom is 6 minus how many restraints we have put on the body, ठीक है, कितने मोशन, 6 मैक्सिमम मोशन थे, 6 वर द मैक्सिमम मोशन, माइनस हाउ मेनी मोशंस वी डिस्ट्रॉयड of that body, that will become its degree of freedom। now I'll give you one more question to solve, so let's solve this question and let's understand how much we have got, so find the degree of freedom, find the degree of freedom of a cylindrical bar in a V block। so किसी V block में आपको एक cylindrical bar है, so what is this V block first of all, so it is a GATE previous year question, mostly the sense of the question is same। so एक cylinder है एक V block में, if you know the V block and you are expected to know it, so V block is a work holding device used in manufacturing lab। if we ever visited any manufacturing labs in our colleges where they are conducting the practicals for you guys, so if you go there, अगर आप कभी गए होंगे वहाँ पे जहाँ पे बेटा आपका लैब्स वगैरह पे V block का यूज होता है, तो अगर आप वहाँ पे कहीं जाएंगे कभी किसी लैब में, तो you will be able to see a V block there, which is used for holding the cylindrical workpiece. So it looked like this, beta. It looked like this. I'll show you how it looked like this. If you, although in examination, no figure was given when this question came. Okay, okay, because we are expected to know about the V block. Okay, so a V block, if I draw it in two dimension, it would look like this. If I draw a V block in two dimension, if I draw a V block in two dimension, it would look like this. If I draw a V block in two dimension, it would look like this. ठीक है, अगर एक V block में एक सिलेंडर को लगा दिया जाए, if in a V block, if we place a cylinder, if in a V block, if we place a cylinder, ठीक है, it is like this. So ये ऊपर क्या होता है? This is the clamp. Now बेटा, as I was telling you in the previous session also, मैं आपको last session में भी एक बात कह रहा था. क्या last session में आपको कह रहा था? तो in the last session I was telling you, in the last session, my dear, I was telling you that we need to imagine the things which look in 2D, but we have to sometimes imagine it in 3D. Now, can you answer me this question? I'll give you 1 minute if you want to find it out. Please answer. Meanwhile, you can, if not subscribed yet, please subscribe the channel. Okay? Please do this question and do subscribe the channel as well. Do share to your friends as well, because more students when join the live session, we may explore even more things. Okay. So what is the degree of freedom of a cylindrical bar in a V block? Please go ahead and do it. Let's see if we can do it or not. चलिए करिए, हो जाएगा, कोई दिक्कत की बात नहीं है, हो जाएगा. कोई दिक्कत की बात नहीं है. Please do it, my dear. Please try to think it in the 3 dimension. 3 dimension means you have to imagine and everything will be fine. ठीक है? 3 dimension में imagine करेंगे and things will be fine very soon. कोई issue नहीं है. Please go for it, my dear. Live student, please respond. So find the degree of freedom of a cylindrical bar. Find the degree of freedom of a cylindrical bar. Find the degree of a cylindrical bar inside a V block. So किसी V block में my dear एक सिलेंडर है, जो कि सिलेंडर को एक क्लैंप लगा करके हमने हेल्ड अप किया हुआ है. Now what will be the degree of freedom? So you have to make some imagination here. You need to have put some imagination here. So now if there is a V block, you understand this. So definitely this figure is in 2D. Now if I extend it in 3D, it will look like somewhat like this. It will somewhat be looking like this. So if we see it like this, so this is going to be in 2D, it will look like this. Right. And there is a cylindrical workpiece over it. there is a cylindrical workpiece over it. Okay, somewhat it is, this is the situation, somewhat this is the situation, and at the top you can have a clamp there. So if you try to imagine it, to some extent it will be like this, it is something like this. Yes or no, my dear? Yes or no? Now if you imagine this, so how many motions this cylinder could do if it is freed up in the space? So if this cylinder is in free state, if this cylinder is free in space, it can have 6 motions. Now as you can see, it is constrained to move as per the arrangement in which it is held up. So if you see, so in, let's say this is your V block, and in this pen is considered less to be a cylinder. So can it move in this direction? Can it move in this direction? No, it cannot move in this direction. Can it move up and down? No, it cannot move up and down. It cannot move up and down. So it has one freedom. Can we say, sir, it has a freedom? Can we say, sir, it has a freedom in this direction to move? Bolo. Freedom to move. So it is having a freedom to move in this direction. Like this. I can move this pen in the direction perpendicular to the screen in this cavity. Is it or isn't it, beta? Is it or isn't it, beta? Is it or isn't it? Also we can rotate it. Also we can rotate it. Also we can rotate it inside this cavity also. So this is one freedom. This is freedom number 1. This is the one freedom. Okay, this is the first freedom. Also, if we imagine a bit, so this cylinder can also rotate about this axis. Yes or no? Can it have the rotation also? Can it have a rotation also? So this is the body, so it can have rotation also, like this, like this. So this rotation, this rotation is your freedom number 2. Now can it have, now do it have, now do it have, do it have, does it have any other motion that it can do? Can it move in X direction, Y direction, right? Can it move? So if I say this is X, this is Y, and perpendicular to it is Z, and perpendicular to it is Z. So this is X, this is Y, this is X, this is Y. So it cannot move in X and Y, but can only move in Z. Similarly, it can rotate only about Z. Okay, it can rotate only about Z. It cannot have rotation in any other plane or about any other axis, because we can see a clamp at the top. So it cannot move like this. So again, if we imagine, so it cannot move like this. It cannot rotate like this. It cannot rotate up and down. It cannot rotate like this. So it can only rotate about Z. So it has got 2 degree of freedom. Now, beta, this subject wants some, some imagination is required in the subject, my dear. Okay, there is some sort of, some sort of imagination is very much required for us. Sir, how will be able to imagine? So we will be able to imagine. We will be able to imagine it. We will be able to imagine it only when we try to visualize the thing. So in theory of machine, it is very, very necessary. In theory of machine, this is very, very necessary. This is very, very necessary that we imagine some things in 2 dimension, of 2 dimension in 3 dimension. Understood, my dear, or not? Please answer me. Is that understood? No, it is having 2 degree of freedom. Now can we answer this? So this is having 2 degree of freedom because it cannot move in any other direction. Now we know degree of freedom is 6 times minus degree of restraints or number of restraints. So sometimes it is called as degree of restraints. Sometimes it is called as degree of constraints. Degree of constraints. So this degree of constraints or degree of restraints are giving us what? So they are giving giving us an indication that how many motions are being destroyed of our body. Okay. Okay. Now let's do one more question. So I hope this question is clear to you. How we can imagine the degree of freedom. How we can imagine the degree of freedom of this body. So let's do this question. This is the GATE previous year question. Let's try to solve this. 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 So what do you mean by type of joint? What do you mean by type of joint in here? So type of joint means we are connecting our body, we are connecting our body with respect to other body, with respect to the other body by revolute joint, by cylindrical joint, by spherical joint. So let's see how many of us can do it. So here they are asking you degree of constraint, not degree of freedom. Let's see. Please give me the answer to this one. Please give me the answer to this one. Let's see if we can solve this one. Please go ahead. Let's see if we can solve this one. Let us see if we can solve this one. So match the following with respect to spatial mechanism. Okay. Match the following with respect to the spatial mechanism. Now, what do you mean by spatial mechanism? So we are talking in space. Okay. So what is the type of joint? So the first one is revolute. So let's do it like this. So in the last session, beta, we have seen the meaning of revolute joint. Remember that? But remember, we are getting asked in 3 dimension, right? Sir, how we come to know we get to ask? We are asked in 3 dimension. So see, there is written no spatial. Now spatial means in 3D space. Whenever this term used spatial or space, so we have this is our revolute pair. No, this is our revolute pair. Now, if you see, if this is not made up pair, so it has 6 degree of freedom. But when it is placed in this body or in this block where it can have rotation only, so maximum degree of freedom is 6. So degree of freedom is 6 minus restraint. Now if you see 6 minus number of restraints, so how many degree of freedoms or how many restrictions are imposed on this when it is joined with another block? So what is your degree of freedom will become to 6 minus 5, that is 1. Because now it cannot move in x direction, or in a way we can say, so it is having only one motion, that is rotation about x axis. It is having no other motion. It cannot rotate in any other direction. It cannot rotate in any other direction. Sorry. It cannot rotate, my dear, in any other direction, but can rotate in one direction only. So obviously it is having 1 degree of freedom. Now if it is having 1 degree of freedom, how many restraints does it have? So definitely it is having 5 restraints, because see, degree of freedom and degree of restraints are related to each other. So if you have the degree of freedom, you can calculate the degree of restraints, and if you have the degree of restraints, you can calculate the degree of freedom. Very, very easy. Right or wrong? Very, very easy, I hope. Is it or isn't it, my dear? Is it or isn't it? Now similarly, if we see the cylindrical, so what the revolute have, how many degree of restraint? So revolute have 2 degree of restraint. So now by itself only we can answer in the examination that P is 2. Now let's just see it. So by cylindrical if I talk, so for cylindrical we just calculated that degree of freedom is 2. So degree of freedom is 6 minus number of this constraints or number of constraints. So degree of constraint will be, what will be your degree of constraints or restraints? What will be degree of constraints? What will be the degree of constraints? So it will be 6 minus number of degree of freedom. Number of degree of freedom. So how many degree of freedom it got? It got 1 degree of freedom. So that will be 5. That will be degree of constraint is 5. So we have put 5 restriction on this body, and hence its degree of freedom has become 1. I hope this is clear to all of you. Now cylindrical is completed. We have 4 this. Now spherical. So if we remember in the last session, we spoken about a spherical pair. Remember? Ball and socket joint. And I showed you picture of ball and socket joint as well, right? So let's get you the picture again. So ball and socket joint, I gave you the picture in the last session. I gave you the real time picture of it. So let's check it out. So we have ball and socket joint. Just give me one moment, my dear. We got some problem, I guess. Just 1 second, my dear. Alright, so I hope now it is okay. Okay. So this was the ball and socket joint we discussed in the last session. Now can you tell me how many degree of freedom it got? Can you tell me how many degree of freedom it got? बताइए. बताइए, can you tell me that, beta? Can you tell me that? See, if you come live and you respond, so definitely this session is going to be very, very successful for you guys. Alright? Please go ahead. Please go ahead. Please tell me what is the degree of freedom of a spherical pair. प्लीज टेल मी द डिग्री ऑफ फ्रीडम ऑफ अ स्फेरिकल पेयर. एक स्फेरिकल पेयर की डिग्री ऑफ फ्रीडम क्या होगी? बताइए, देख के बताइए. So it is somewhat like this, no? I told you a spherical pair, so it moves 3D rotation, like you can see my hand. So I think you can see my hand. So this hand can move like this, can move like this, can move like this. But it cannot leave my bicep and go away from it. ये मेरे इस part के, so my body, let's see my body, this part of my body and this part of body. So with respect to this part of the body, this can move like this. this can move like this, and this can move like this, but it cannot go in this direction leaving this part if I am not a, if you are not supernatural person, अगर आप सुपर नेचुरल कुछ आपके अंदर कुछ शक्तियां नहीं है शक्तिमान टाइप की, तो आपके हाथ का ये जो हिस्सा है ये इस हिस्से को छोड़ करके ऊपर नहीं जा पाएगा, ना उस डायरेक्शन में चला जाएगा ना इस डायरेक्शन में जा पाएगा, राइट. So how many independent motions are there? So it can have 3D rotation. If you remember, I marked this also, I said it in the last session also. So it possesses 3D rotation. Now 3D rotation, but no independent moment in X, Y and Z. So it got 3D rotation only as explained. So when 3D rotation it is having, so what is the degree of freedom of it? Degree of freedom is 3. Okay, how sir? How sir? You seen anyway. Either you can see while solving the question of three-dimensional cases, either you can see, remember, either you can see how many motions are left, we are left with, how many motions are there that are left with, okay, कितने motion रह गए हैं या कितने motion destroy हो गए हैं, because you have to subtract 6 from it, or you have to subtract this from 6 to get the other thing, right बेटा. जैसे डिग्री ऑफ फ्रीडम 3 है, तो व्हाट विल बी द डिग्री ऑफ कंस्ट्रेंट्स, व्हाट विल बी द डिग्री ऑफ कंस्ट्रेंट्स, सो लेट्स कॉल इट डिग्री ऑफ constraint. So degree of constraint will be, if degree of freedom is 3, degree of constraint would be 6 minus 3, that is 3. Understood, my dear? Understood. So I hope from this discussion, the degree of freedom, how to see it in 3 dimension is clear to you. Now, beta, now we'll be moving in 2-dimensional system. We'll be moving in 2D system. Okay, we'll be stepping into 2D system now. Now I want to ask you something. Okay, I want to ask you something before I proceed. I want to ask you something. So let's say there is a link or there is a body. So when I say 2 dimension, so I mean like this. Okay, let's make a body like this. Okay, so this is, let's say, the same body there that from which we understood how to see the degree of freedom in 3 dimension. So let me say that I have reduced this thing into 2 dimension. I have reduced this thing into 2 dimension. So when I reduce this thing in 2 dimension, this is going to be the case, right or wrong बेटा? कुछ इस तरीके की बात बन जाएगी. Say yes or no. Say yes or no. कुछ इस तरीके की बात हमारी बन जाएगी. भाई एक्स वाई तो कोऑर्डिनेट सिस्टम हो गया, और एक्स वाई तो कोऑर्डिनेट सिस्टम हो गया, और 3D बॉडी को 2D में देखोगे तो ऐसा दिखेगा. Now if I say, if a body is in 2D space, if a body is there in 2D space, ठीक है, तो जैसे पीछे हमारी बॉडी थी बेटा, पीछे हमारी पर्टिकुलर बॉडी थी, अगर पीछे हमारी पर्टिकुलर बॉडी थी 3 डायमेंशन में, तो वो मैक्सिमम कितने मोशन कर सकती थी? दैट कुड डू 6 मैक्सिमम मोशंस. वो मैक्सिमम 6 मोशन कर सकती थी. नाउ दिस बॉडी इज अ 2-dimensional बॉडी इन 2-dimensional कोऑर्डिनेट सिस्टम. सो हाउ मेनी, व्हाट इज द मैक्सिमम नंबर? सो दिस इज द क्वेश्चन ऑफ माइंड. सो मैक्सिमम नंबर, what is the maximum degree of freedom of our 2D body in 2D space? So can somebody please answer me? This? So what is the maximum degree of freedom of a 2D body in 2D space? 2D space में 2-dimensional coordinate system में अगर कोई बॉडी है हमारी, अगर 2-dimensional coordinate system में अगर कोई बॉडी है हमारी, ठीक है, तो उसकी मैक्सिमम डिग्री ऑफ फ्रीडम कितनी होगी? कैन यू आंसर मी प्लीज बेटा? कैन यू आंसर मी दैट? क्या आप आंसर कर सकते हैं माय डियर? क्या आप आंसर कर सकते हैं माय डियर? कैन यू प्लीज आंसर मी दैट? कैन यू प्लीज आंसर मी दैट? बताइए. प्लीज सोच के जवाब दीजिए. प्लीज आंसर मी. सोच समझ के जवाब दीजिए. आई एम वेटिंग फॉर योर रिप्लाईज बेटा. आई एम वेटिंग फॉर योर रिप्लाईज माई डियर. मैं आपके रिप्लाई का वेट कर रहा हूं माई डियर. प्लीज आंसर मी. Please answer me. I am waiting. I am waiting, my dear. I am waiting. I am waiting. I am waiting for your replies to come, my dear. Please respond. Don't afraid. गलत होगा सही होगा. So now I want you to do one thing. What I want you to do, I want you to do one thing. I want you to do one thing. I want you to do one thing. So I'll give you option. Either it is 3 or it is 4. What do you say? 3 है या 4 है? Please answer me. Please respond. Please respond. I am waiting. Respond करिए. Please respond. I am waiting for it. Please respond. I am waiting for it. Please respond. I am waiting for it. बताइए. बताइए. None answer. No answers. No answers. Okay. Okay. So sometimes people think it is 4. So when you will be seeing it, some of you might be thinking sir कि ये 4 होगा. ये 4 होगा. कैसे 4 होगा सर? कैसे 4 होगा? तो one will say sir slide in X direction. This is one motion. Slide in Y direction. This is another motion. Rotate in X and rotate in Y. Now when you will be watching this video, definitely if you are giving the answer 4, definitely this is something that is coming in your mind. So I'll tell you, no, this is wrong. This is wrong. First of all, rotation in X, rotation in Y itself is a wrong statement. Itself is a wrong statement. ठीक है, ये अपने आप में ही एक wrong statement है. Why it is a wrong statement? Because rotation happens about the axis, not in the axis. ठीक है, reciprocation axis in the axis होता है, मतलब axis से parallel होता है. लेकिन भैया यहाँ पे सॉरी रेसिप्रोकेशन एक्सिस से पैरेलल होता है, लेकिन रोटेशन कोई चीज जब रोटेट करती है, सो नाउ प्लीज अंडरस्टैंड दिस एक्स वाई एंड जेड. जब 3D में बात करता हूँ, थोड़ी देर पहले बोला था, तो रिमेंबर दिस, लोगों को बहुत कंफ्यूजन होता है. तो रोटेशन इज अबाउट सम एक्सिस, रोटेशन इज ऑलवेज अबाउट सम एक्सिस and in some plane. Rotation is always about some axis and in some plane. Getting my point, beta? Getting my point, beta? Rotation is always about some axis and in some plane. Now, if the rotation happens about x, so it is like this. Okay, so rotation happens about x. That means the rotation is taking place in a yz plane. Similarly, rotation happens about z. That means the rotation is taking place in xy plane. and rotation happens about y means the rotation is taking place about horizontal axis in xy plane. In xy plane. So when I say this body, so this body actually, this is the correct one. This is the correct one. So this body, so this is wrong. This is wrong. So this body will slide in x direction. This can slide or reciprocate in x direction. It can reciprocate or slide in y direction. Plus, along with this, what it can do, it can rotate and rotate about z in xy plane. So it can rotate about z but in xy plane. Getting my point beta or not? It is rotating in the direction. So y, so what we can say, this is the thing beta, this is the thing. So our two-dimensional body in the space have maximum 3 degree of freedom. So what is the maximum degree of freedom of a 2D body in a 2D space? So it is 3. It is 3, 2 reciprocation and 1 rotation. So the rotation is actually not happening either about x or y, but it is happening about z, because this body can only rotate in this plane xy. So what we can say here, rotate about z in xy plane. Getting my point, beta? Rotate about, so this body can rotate about x, not x, not y, but in about z direction in one plane, that is xy plane. So always remember, my dear, rotation always happens in a plane. It never happens in a direction. It happens in a plane about some axis. So I hope beta this is clear. So in this session we will keep it up to this point, and in the next session beta we are going to talk about the degree of freedom of a mechanism. That is, we are going to talk about the Kuchback relation, we are going to talk about Grubler equation, and we will be solving a lot of questions for sure. Okay. So from the next session onwards, you will be seeing, because this is the theoretical part and from this so many questions are coming. So I am trying to put this in a way that you can answer that. I am trying to do it in a way so that you can answer all these theoretical aspects of this subject. Okay, so from the first topic, the question that you will see in the examination are mostly of theoretical sort. So in the next session onwards, you will be seeing the numericals flowing in. There will be so many numericals that will come to flow. So what is going to happen in the next session? Let me briefly tell you that. So for the next session, so what is the content for the next session? And the next session is going to happen day after tomorrow. Okay, so next session is going to happen day after tomorrow at the same time. Right? So for the next session, this is the content we got. So in the next session, so right at the start, we will be seeing the degree of freedom of a mechanism. So in today's session, we understood the degree of freedom to some extent. So in the next session, we are going to see the degree of freedom of a mechanism. We'll be doing the interpretation. Interpretation means, so if degree of freedom is 1, what does that mean? If it is 2, what does that mean? If it is 0, what does that mean? If it is negative, then what does that mean? So we are going to see the interpretation of degree of freedom of a mechanism. Interpretation of a degree of freedom of a mechanism, right? We will be seeing Kuchback equation. We will be seeing Grubler's criteria, and we will be solving so many questions. We will be solving so many questions, right, beta? So do come in the next session, please. Okay, please try to share this with your friends also, if possible. If you are liking the session, if you are finding it helpful for you, and as I said previously, also so many subjects. So many subjects are running in the Testbook Gate channel and absolutely for free. So SOM is running, Thermal is running, FM is running, HMT is running, Mathematics is there. Now Theory of Machinery started just now. So all the subjects you are getting for free on this channel. So definitely please subscribe for it. At least this much we can demand. And please share it to your friends so more students may join live or may watch the video, and definitely that will be helpful for them. Okay, so with this, thank you very much. Do not forget to like and subscribe. Do come in the next session also. So thank you very much. Thank you for listening for me. And for any feedback, any comment, feel free to write it. We'll be happy to answer. Okay, so thank you very much. With this, I would say goodbye, and we'll see you in the next session.